110 balanced binary tree. Given a binary tree, determine if the height balance, if it is a height balance. For this problem, a height balanced binary tree is a binary tree that the left and right subtrees of every node differ in height by no more than 1. Let's see what does that mean. So this is the binary tree that is given to us. The left node of the node 3 and the right node of right node, they have no difference, but the left node and the right node, the difference is by 1 because the node 9 has no children. So this is a balanced binary tree. How about this one? This is not a balanced binary tree because the left node, the height is like 1, 2, 3 nodes that we have here, but the right side we have only 1 node, so the difference is more than 1. So this is not a balanced binary tree. And if we have no node, something like this, we are going to return true. So the number of nodes that we are going to have is going to be either 0 to 5,000. Let's see how we can solve this problem. When we talk about binary tree and getting the height and like seeing if it is balanced or not, what we can do, we should traverse the tree and get the height for the left node and right node and get the difference, and if it is more than 1, we are going to return false. For doing that, we need to traverse the tree, and we are going to use DFS because we need to go all the way to the left and see what is the height here, and all the way to the right and see what is the height there, and then compare them, and then we can decide if it is going to be a height balanced binary tree or not. For this problem, we are going to have a variable called balance, and by default I will consider the tree is a height balanced binary tree. The reason that we are putting self there because we want to update this one and we don't want to have a like different balance variable every single time. Then I'm going to use a helper function. I will call it height, and I will pass a node to it to get the height of that node, right? And I'm saying if not node, if the node is like it's empty and there is no node, we are going to return -1. Otherwise, we are going to get the height of left side and height of the right side. To get the height of the left side, I'm going to call this height function recursively for the left nodes. And then I'm going to call the height function recursively for the right nodes. After calling them recursively and getting the height, I'm going to get the absolute difference of left and right. And if it is bigger than 0, if it is bigger than 1, we know it's not a balanced binary tree, so I'm going to update the self balance to false. And at the end, I'm going to return the height. I'll get the max of left and right. So the max matters here, right? And after I'm done with this, I'm going to call the height for the root, and finally I'm going to return self.balance as a result. Whatever that we have in self.balance is either true or false. This is the result that we are going to return. Let's run the code and see how it works. It works, and the time complexity for this is linear because we are traversing the tree, and we traverse every single node, and the space complexity is linear as well because we are calling the height function recursively. Let's go through an example and see how it works. Let's say this is a binary tree that we have, and we start with balance true, and we start calling with the root node, which is 1 here. So I'll call it for the root node, I will call height for the root node 1, and then I check if it is not empty. If it is a node, yes, 1 is a node. So what I'm going to do, I will traverse the left side and the right side. I will call the height function recursively for the left, which is going to be 2. And so it will recursively call this function. So it will call height for 2 and it checks if it is node, a valid node. Yes, it is. So it will call the height function for the left side again. So it will call for 3, and then it will call for 4, and then it will call for none at the end, right? And what will happen here is, so we are at the end of the tree, so it's going to return -1 for this one, right? So it will return -1 here, so it's going to be -1 for this one, and it's going to be -1 for this one as well, right? And so we have the left one and the right one. Their difference is not bigger than 1. What will happen here, their difference is not bigger than 1, so what will happen here, we are going to get the maximum of left and right, so it's going to be 1 plus maximum of -1, and -1 is going to be -1, so the height is going to be 0 for here, right? And then we are done with this node. Now we are going to call for the right side. We call it for this node. The same thing is happening here, and so on. And finally we get to the point that the difference between left and right is going to be 3 and 1. For this one, this is going to be 3. For this one is going to be 1, which is the difference is bigger than 1. So the balance is going to be false, and we are going to return like balance, which is going to be false as a result. So this is how it works. Thank you.